This is 3.7, factoring by division. So your essential question, how do you use synthetic division to help you factor polynomial functions? So sometimes we get stuck, right? And I'm going to warn you, a lot of the problems you're going to see in this and future, for like review and the test, can't be factored right away. We can't just factor it right away. A lot of people want to see the four terms and just go straight to grouping. After this, you got to really think, can I factor? And there's always going to be one very, very clear thing that they're going to give you that will tell you you have to factor it first. Okay. So here are the steps required for synthetic division of a polynomial. Step 1, to set up the problem, first set the denominator equal to 0 and find the number to put in the division box. So the thing we are dividing out is a 0. So if they give you a factor, you have to find the actual value of x. If they give you a 0, you can just put it, and we call it this thing called the division box, which you'll see. Next, make sure the numerator is written descending order, and if any terms are missing, you must use a 0 to fill in the missing term. Finally, list only the coefficient in the division problem. Okay, so we got to make sure every single exponent of x basically is involved. That's one thing, and it has to be in descending order. So if we have to reorder it, highest exponent to lowest exponent. Okay. Once the problem is set up correctly, bring the lead coefficient, the first number, straight down. Step 3, multiply the number in the division box with the number you brought down and put the result in the next column. Step 4, add the two numbers together and write the result in the bottom of the row. Okay. One thing I want to take note of is you add them. Okay. Step 5, repeat steps 3 and 4 until you reach the end of the problem. So you have multiple rows, you just keep doing steps 3 and 4 over and over and over again. And then step 6, write the final answer. The final answer is made up of the numbers in the bottom row, with the last number being the remainder, and the remainder must be written as a fraction. The variables or x's start off 1 power less than the original denominator and go down 1 with each term. Okay, that's a lot, but we'll talk about it. Once you see it, it's not too difficult actually. All right, so you divide using synthetic division. I'll give you a little hint. We already know this one. We're starting with this one because it's something we can factor, so we can see the division in action. So if I told you to factor this, you'd look at your factors of 10, right? 10 and 1, that doesn't make 3. 5 and 2, ooh, that does make 3. So I know it's going to be x minus 5, x plus 2. If I factored this, that should be my result. Okay, and notice we're going to divide x plus 2. Okay, and we'll talk about how to see if it is a factor in just a second. So if I divide out x plus 2, I should get the other factor as my answer. So x minus 5 should be my answer here. Okay, we know that. We're going to see it in action now. So first of all, we're going to have what's called the division box. Then we have the one row, the second row, and then our answer under the line. Okay. So you have division box first. So to put the number in the division box comes from the factor you're looking at. Remember, it's the 0, so we set it equal to 0. X plus 2 equals 0, so x equals negative 2. That goes in the division box. Then I look at my coefficients. It has to be all x involved, so x squared, x to the first, and then the constant, so we're good. It has to be in order, it is. And then we put the coefficients in front, so positive 1, negative 3, negative 10. Okay, then it says we bring the first one down, so 1 comes down. Then we multiply with the division box, so 1 times negative 2 is negative 2. So that goes there. And then we add negative 3 plus negative 2 is negative 5. Then we multiply. Negative 5 times negative 2 is positive 10. Then we add negative 10 plus 10 is 0. And, well, that's actually the end, right? That's our last row, so we're done. This number, I always circle it because that is our remainder. This time it's 0. And then we have our answer. Okay, these answers are actually the coefficients. So we have to look at our exponent. In this case, it was a 2. That means this one starts with a 1. So at 1x to the first. So it doesn't have to do with this. This is the coefficient. It has to do with the exponent you started with. Since it started with a 2, we go down 1 to get our exponent. And then minus 5, technically x to the 0, which is this constant term. Okay, and you can kind of see this simplifies to x minus 5. And we have divided out x plus 2 And notice it's our other factor. So, is this a factor? The answer is yes, because the remainder is 0. When our remainder is 0, that means it is a factor. And so we can factor it, basically, using that. Okay, example 2. So this one is not factorable. If we used grouping, if I get to pull out an x squared, I'd have 2x minus 5 and 3x plus 7. Remember, they have to be exactly the same. So only possible way to get through this is synthetic division. So we're going to look at this. We're going to divide out this, and we're actually going to see if it's a factor. It might not be in this case. Once we get to the factoring by division, they are all factors. So I set it equal to 0, and I get, x minus 2 equals 0, add 2, and I get x equals 2. So that goes in the box. The 0 goes in the box. Then we need all of our coefficients. Check. Do I have all the exponents? 3, 2, 1, constant. Good. They're in order, so I just use the coefficients. Positive 2, negative 5, positive 3, positive 7. Bring down the 2, because we always just bring down the first one. Then we multiply. 2 times 2 is 4. And add. Negative 5 plus 4 is negative 1. Then we multiply. Negative 2. Add. Multiply. Add. And we circle the last thing. That's our remainder. So in this case, is it a factor? No, because the remainder is not 0. So it's not a factor, but we still need to be able to write the answer. So remember, we take the exponent. So it's going to be x squared, because we go down one exponent, and then these are the coefficients, the numbers in front. 2x squared minus 1x plus 1 plus, we actually have a remainder now, so we have to know how to write it. If you remember from division problems, the remainder you put over the thing you divide. So in this case, we divided by x minus 2, so it's 9 over x minus 2. And that's our answer. Not a very nice number, because or not a very nice answer, because when we divide, it wasn't a factor, so it looks kind of gross. Okay. Example 3. Divide using synthetic divisions. Now we're just going to divide. There's no question, is it a factor? We're just going to divide and get the answer. So x minus 2 equals 0. That means x equals positive 2. That's the number that goes in the box once again. We need all of our things. Oh, there's one missing, right? It goes 4, then 2. So I need a 3. So when I write out my coefficients, I have the positive 1 for the 4, and then I have a 0 for the 3, because remember, we have to represent everything, and if it's not there, we put a 0 in. Then negative 2, positive 5, negative 3. Okay, bring down the first one. Then we multiply, add, multiply, add, multiply, add, multiply, add. That's the last one. So this one would not have been a factor because we have a remainder. And then remember, we take the exponent and go down 1. So from x to the 4th, I go to x cubed. And then these are the coefficients. So 1x cubed plus 2x squared plus 2x to the 1st plus 9 plus the remainder over the thing we divided by, which in this case is x minus 2. Okay, we can clean it up just a little bit. And we have divided out x minus 2. Okay, when we divide for factoring, they're going to be factors. Okay, so it's not going to have this nasty fractional thing on the end every time. So that's what the last 2 examples are. So factor completely given a factor of f of x. Sketch the graph. Label x and y-intercepts. All right, so we have a lot of work to do here. So first we have to factor this out. So they're giving us the factor x minus 4. So I need the 0, which is positive 4. That goes in the box. Okay, I got to make sure I have all x cubed, x squared, x constant. Good. 2, positive 3, negative 39, negative 20. Bring down the first one. So multiply, add, multiply, add, multiply, add. And remainder is 0. Okay, remember that last one is a remainder, that's why I always circle it. Alright, so in this case, we go down one exponent. So I had x cubed, so I'm going to start with x squared. So it's 2x squared plus 11x plus 5. Okay, but remember, that's dividing out x minus 4. So if I'm trying to factor, that's one of my factors. I've taken it out. It's a factor, right? The remainder is 0, so it's a factor. So I take it out. And so I have this after division. Now we just have to finish factoring. Okay, so I have 2x and x. I have positive 5 and 1. I need to make 11. So 2 times 5 is what I'm thinking when I factor. And we will always check. So I have 2x and x. The x minus 4 is just along for the ride at the end. I want to multiply the 5 and the 2, so I'm putting it there. And they're going to be both positive, because I need to make a positive 5 and a positive 11. So now we check. 1x plus 10x is 11x. Checked. Done. I'm factored. Please don't forget, the thing you divide out, this thing, is one of your factors. Okay? Because we're factoring the original problem. When we divide it out, we have taken out a factor, and then we just have to finish factoring, basically. Okay, so that is my factored form. Then I need my degree, my lead coefficient, and my in behavior. Okay, so I look at those things. Degree, I'm going to go back to my original function. Standard form is the easiest for me to look at. Positive, it's a third degree because it's exponent of 3. Positive 2 for my lead coefficient. And then odd positive, down, up. Okay. Then I need my X-intercepts. So set 0 equal to y. Remember, f of x is the same as y. Okay, so 2x plus 1 equals 0. X plus 5 equals 0. X minus 4 equals 0. So I subtract 1, divide by 2, subtract 5, add 4, and then don't forget about their multiplicity. So negative 1/2 with a multiplicity of 1, right? The multiplicities are the exponents. Negative 5, 0 with a multiplicity of 1, and positive 4, 0 with a multiplicity of 1. And finally, y-intercept, set x equal to 0. So I get 0 plus 1 is 1, 0 plus 5 is 5, 0 minus 4 is negative 4, so that's negative 20. 0, negative 20 is my y-intercept. Okay, so I have labeled my x and y-intercepts. I have factored completely. Now I just need to sketch the graph. Okay, so we have negative 5, 2, 3, 4, 5, negative 1/2, and positive 4, with a negative, remember those are multiplicity of 1, so I'm going to cross all of those. Negative 20 y-intercept, so I start low in behavior, and high. Sketched. Done. Okay, so we used synthetic division to help us take out one factor, which left a factorable problem, and that's what's going to happen every time. It's never just going to be division and done. You're going to have division, then some sort of factoring. Okay. Example 5, this time they're giving us the 0. Okay, giving us the 0 helps for synthetic division. I know what I'm going to put in the box. It's negative 1. But a lot of people forget that they also need the factor, right? When we write it out, we're going to take out this factor. So what factor gives me negative 1? Well, x plus 1, right? So I'd subtract 1. That would give me the 0 of negative 1. So x plus 1 is my factor. Don't forget that. Do we have all the exponents? So I have 3, 2, 1, constant. Yes. So I just have the coefficients. Positive 1, positive 4, negative 15, negative 18. Bring down the first one. Multiply, add, multiply, add, multiply, add. and remainder of 0. That's good. If you're solving a problem like this where it has you sketch, better be a factor, meaning remainder of 0. Okay, so we have taken out the factor of x plus 1. So first of all, we look at this. So it's x cubed. That means we go down to x squared. It's 1 positive 1x squared plus 3x minus 18. That is y after I've factored out x plus 1. So don't forget that factor you write out. Now we finish factoring. This one's an easy one because it has a coefficient of 1, so it's x and x. And then I have to think, well, which one makes 3? And I could write 18 and 1. That doesn't work. 9 and 2. That doesn't work. 6 and 3. Ah, there we go. It's negative. 3 is positive, so I think it's going to be x plus 6, x minus 3. That makes negative 18. And then we check positive 6, positive 6x minus 3x is indeed positive 3x. It checks. Write our last factor, which was the one we divided out, and we have our factored form. Okay, so now I need my degree, my lead coefficient, and my end behavior. So my degree is, looking back at the original problem, 3. The positive one. Once again, they're not all going to be down up. These are just the easiest to write. So that's why my notes end up with a lot of them. X-intercept. Set 0 equal to y. And then I have these. They all are multiplicity of 1 again. Don't forget how to deal with multiplicity of 2, which gives you a bounce. Just trying to introduce the new things, not bog you down with all the other stuff in these notes, so they go a little quicker. So I get negative 6 comma 0 with a multiplicity of 1, positive 3 comma 0 also with a multiplicity of 1, and negative 1 comma 0 with a multiplicity of 1. And then finally we need the y-intercept. So I set x equal to 0, so I get 0 plus 6, 0 minus 3, 0 plus 1, so I get positive 6 times negative 3 times positive 1, and so it's negative 18. So 0 comma negative 18. I have labeled my x and y intercepts. X-intercepts have their multiplicity listed. I have my end behavior, my factored form. All I need is my sketch now. So negative 6, 1, 2, 3, 4, 5, 6, negative 1, positive 3, with a negative 18 of y-intercept. Starts low, ends high. And there we have it. Okay. So write your 3-sentence summary.